Hi, everyone. My name is Leonard Lee. I'm the executive analyst and founder of Next Research, firm that I started about 6 years ago. And hey, you know what? I have to admit, I'm a little bit nervous here because I have to follow, Chetan and Roy Chua, who I consider, master comedians, and I feel like I'm like the not so funny comedian that has to follow them. So, but you know what? I want to thank Anand and the folks at Aira Technologies for inviting me here to moderate this panel. And full disclosure, when I told my friend I'm going to be moderating a 6G panel, they said, "What? You, Leonard Lee, moderate a 6G panel?" They were just in disbelief. But I told them, "Hey, look. It's okay. It's okay. And, it's okay to have a 6G discussion as long as you are talking to folks who know what they're talking about." And I think we have a really fantastic panel up here, and I know that you guys know what you're talking about, right? Right? Come on. Oh, I want to see a little bit more confident. Yeah.
ChatGPT will hold us.
So while we go down the row, quickly introduce yourself because I know we're a little bit, short on time probably because we're a little bit late. But I think we really want to get into the discussion because everyone's wondering what 6G is all about, right? And what it has to do with what's beyond intelligent RAN, and what intelligent air influence. So why don't we start at the end there, if you can?
Okay. Hello, everyone. Kiran Mukkavalli from Qualcomm Wireless Research. I lead our systems research, 5G Advanced, 6G, and I know there were a lot of discussion in the back of the room. I think just before this panel, 6G, why 6G? Should you not make 5G work right now? And yes, we'll answer all those questions as well. We'll make 5G work, we'll make 5G Advanced work, and that will lead into 6G. And maybe just a little bit of what exactly we do as part of our wireless research there, even before 5G got defined and standardized. My team is the one that actually comes up with this initial notion of what could be different from the previous generation. And I'm sure that's exactly what we'll start getting into today here as well, as part of what should be different for 6G compared to 5G, or what should we build upon. And as part of that, we come up with some initial designs. We do the prototyping. So we have our own OTA network that we operate where we come up with the initial infra solutions as well. So we build our base station, we build our proto UAs, we make the air interface work, we show some of the initial KPIs and use cases and things like that. So we did all that with 5G, and now in the process of doing all of that with 6G. So that's one component of what we do, the initial designs and the prototypes. And then my team also goes into standards as well. So very much in thick of action in 3EPP. And then there's a part of the team that also goes into RAN standards, and they also take care of that. So, but anyway, in a nutshell, that's what we're up to.
Good stuff. Udayan Mukherjee, I work at Intel. So I've been doing wireless and communication research, and now I do product architecture as well for last 20 plus years. So actually, 6G brings up a lot of emotions in people's mind. I mean, I'll tell you a story. With an operator, I was there a month back, and their corporate VP was saying that, hey, in my organization, I have a rule. If anybody says 6G, we fine him $25. So imagine him being here today, But what 6G we are focusing on, and there's a lot of discussion happening, is about creating services. These telcos are dying, literally. There are asset sale going on in Europe. So essentially, extreme KPIs are really no-no. I mean, you have throughput, you have bandwidth, and a lot of this. But now, how do you turn this network itself to a cloud and provide service? A lot of activities are happening on these things. I also own standards organization now, as in addition to my product hat. So we are talking about a lot of in NextG Alliance, in 3GPP and others about actually how do you actually create additional services that can be monetized, turning network as itself as a cloud. So, and AI plays a big role in that as well. We'll talk.
Maria Lema. I'm CEO and founder of Weaver Labs. We are a startup based in the UK, and we build orchestration software, so end-to-end orchestration management. I'm a researcher as well, and we do a lot of research on 6G, in particular, how it can actually drive open networks. I think 6G is a fresh new opportunity to actually deliver on all of the things that 5G did not deliver, particularly in the Open RAN component of 5G. So 6G has the potential of having Open RAN as the de facto deployment model. And Weaver Labs, we are part of a government-funded 12 million project where we are actually building the next generation blueprint architecture for 6G, introducing new concepts such as a knowledge layer with AI and cognitive plane to actually drive end-to-end orchestration. And yeah, why do we do that as a small organization? Well, because we kind of lost hope on 5G being open networks and actually potentially looking at a diversified and densified supply chain. But we believe that if our product is able to evolve into a 6G architecture and therefore continue in the open network ecosystem, we are future-proof for the future of telecommunications in general.
Okay.
Very quickly, in case there are folks within. Yeah, so I'm Ravi. I'm the co-founder, CTO of Aira Technologies, and you all know what we kind of work on if we sat through the demo, but very quick, very short introduction about Aira is we believe in a data-driven approach to designing and developing wireless communications. I come from a wireless communication development background, and I remember running models on MATLAB for days on, and we're trying to see if that can be powered by AI and powered by real data that's being captured over the air rather than models and kind of conceptual.
Okay, wonderful. Well, I wanted to start off the discussion here by setting the context, right? And having the aid of the panelists here in helping to define, well, what do we mean by 6G, right? What do we think 6G will entail? What's its purpose? And what do we think we're going to get beyond what possibly could be what we get from 5G advanced, right? Which we still have to work on, right? So what is this vision statement, and what are some of the expectations that you have for 6G? Anyone want to start?
Yeah, I can go first. Yeah, so when we talk about 6G, and there's always this discussion about, do we need 6G? Should 5G be the last year? I think that was another comment that was made earlier today. Is it just a matter of nomenclature? And we also have to think about, how the industry works, how the deployments work, how the entire ecosystem is set up. So we had 5G, and 5G, the expectation with 3GPP is start off in release 15 with a study item release 14 and goes on till release 20, where release 20 is going to be the study item for 6G. So what's deployed right now is release 15, and very few features beyond release 15 are actually making it to the real networks for various reasons, and I'm sure we'll address some of those here as well. But then the innovation does not stop. So there are, already you see that there are 4 releases, and a lot of things were developed, tested, standardized, but then they don't make it out there. So what's the avenue to get them out there then? So the way the wireless ecosystem has worked so far is it's a collection of everything that you've done up until that point, and then you say, okay, it's a new G where I'm bringing in all these features on day one. This notion of what feature is ready on day one, that actually ends up being extremely powerful, and for a reason. Just because, okay, so let's say, release 15, we have the network, the deployment, which is all release 15 compliant, the devices that come in, which are all release 15, till 16, 17, 18 come in. And the way 3GPP works is, you may have a device that comes in, which is release 17, release 18 compliant, okay, with all the new features that we developed, whether it's power savings or capacity improvements, whatever it is. But the network, first of all, you need to have the upgrades on the network. And the second thing is the network always has to think about, what do I do with my legacy devices? There is a release 15 device sitting out there. Is this change backward compatible? Can I do this in a brownfield deployment? And is it only for greenfield? It turns out that a lot of features that we come in with later, it's difficult to push them into a brownfield deployment just because you have to have this continuum of devices that you have to support. And that's one reason where 6G or the G transition gives us a clean break that, okay, this now can all be part of your day one features that's going to be deployed on the network side, on the device side. The ecosystem is going to support all of this, and then you move on from there. So unfortunately, that's how the system works, and that may be one way to justify 6G. But otherwise, if you look at what would actually end up being 6G, and again, no one has a crystal ball, but just looking at what's coming together as technology that could be a 6G enabler, it's really going to be a collection of what's happened in 5G Advanced. We have release 18, 19, 20, which is all now going to be part of 5G. And AML is getting studied and defined in a big way as part of 3EPP studies right now, starting with release 18. There's a little bit in release 17 as well. Release 19 is going to specify that most likely. Or features like subband full duplex, and whole collection of features. But then to be able to go deploy those in the network right now, unless it's a greenfield network, that's going to be a tough challenge. And that's where I think 6G is going to bring all of these on day one with a big bang.
Okay. Well, does anyone disagree with him?
No.
Sorry, more than a disagreement, I think that the way that at least we are approaching the view of 6G with the vendors and the universities is more of not an evolutionary 3GPP dominated network, but more like a multi-access. And I really liked the title of the panel because it said intelligent air interface and not, RAN as in like 3GPP type of RANs. So we introduced a concept that it's called the matrix, which is the multi-access radio intelligent controller, that it is that aggregation of all of the access technologies. So not just the features that 3GPP bring, but also Wi-Fi, satellite, fiber, and Wi-Fi and other access technologies that are not necessarily wireless in itself. And that also applies for the front haul and the back haul and any other. So it's basically embracing that network of networks. And maybe removing a little bit the power of 3GPP dominated technologies that usually kind of like lag in the
Take years.
years, exactly. That's
Udayan,
the biggest issues.
So it looks like you have something.
No, so I agree. So I mean, the title is intelligent air interface, not 6G.
Right.
Last time it says 6G. So you don't have to even wait for 6G. A lot of the stuff you're talking about. Yeah. I mean, something that Ravi showed today. There are two set of data coming. One is the network data that you already collect. The whole bunch of channel stations at whatever level you have. And you can use that data to actually optimize the network. Traditionally, telcos are doing it, but you can do even better. But then there is also sensor data. There are a lot of other user data that you can tap in at the right place to use the same harness of ChatGPT and others to actually create additional monetization service. The same operator I talked about says that, hey, I have all the data about my subscribers, but Google makes more money. So what is that? That's the dilemma. I mean, you can throw in 6G and others. And about technologies, yes. I mean, you talk about AI. Release 17 talked about load balancing, some of the power management and stuff. Release 18 talks about air interface side of it, which is somebody mentioned about the stuff we're talking about, beamforming, beam management, and the other location and those stuff. And then it will continue. But along with that, how do you bring this together? You don't have to wait till 6G. Talk about it right now. And these are you cannot say it's an incremental stuff, but these are actually adding values. Either you are reducing the operations cost with the AI, or you're trying to create more services out of it.
Right. But, here's the thing. What my friends at Qualcomm always say is that when you're looking at the next G, there's always this long road of investment as well as research in new technologies, right? And so, as we look at the RAN, this notion of intelligent RAN, which I think you're alluding to, hey, we're going to get to some degree of intelligent RAN in 5G Advanced. That agenda is set.
Right.
But, I think what would be really interesting here is get your everyone's thought on, well, what would be beyond that? I mean, what would be beyond an intelligent RAN? And what does an intelligent air interface mean? I mean, Maria, you're suggesting, hey, it could be multi-access, right? It's not just quote unquote traditional cellular. It might be something converged, and wireline plus all the various flavors of wireless. But I mean, if we can think about that as well, because as we think of 6G, and I think that is kind of what we really want to talk about here. What are those investments that are being made? And I think later on we're going to talk about AI and what we think the role of AI will be in that evolution of the network and going into the next generation, right? So, Ravi, any thoughts there?
Yeah, so first I want to follow up on where Udayan was going and tie into some of what you were asking, which is the way we think about 6G from an Aira perspective is how are networks and UEs and base stations going to behave 6, 7, 8, 10 years from now, rather than think of it as a new standard.
Yeah.
So, or other way of looking at it is, instead of thinking of them as new features or new feature sets that are being added or capabilities that are being introduced, how is the existing networks going to behave in the way they think about data, the way they think about processing. And we once again think that, like, for example, I was just asking one of my team members, the RAN today just in 5G is so configurable. The air interface, if you look at a data packet that's going over the air, it's supremely configurable, but how often is it configured? And how dynamically is it being configured? And are there mechanisms today for this configurability to be done on one end and communicated to the other end? One end being the vendor and the other end being the UE. So there is tons of, we feel, potential just being untapped. And that's just not the way these have operated so far.
Sure.
Set a particular configuration and the vendor sets it and they set it based on certain criteria. And one of these, when we talk about Aira, we were, especially on the beam management side, we used to say that the algorithm that's running in Ohio, rural Ohio, is the same signal processing algorithm that's running in downtown New York. And that's just not necessarily efficient. And how do we introduce or normalize the idea that these things have to be very dynamically configured, and this configuration needs to be communicated in a way that's understandable on both ends.
Okay. So, one of the terms that actually came up quite a bit in previous panels, and we've actually talked about this, as we're preparing for this unscripted panel discussion, is scaling. Being able to scale intelligent capabilities across the network. And to your point, right now, things are pretty static. And there was a mention of TM Forum's maturity curve, or whatever, the autonomous network scale. How far do you guys think we're going to get with 5G Advanced on that scale, in terms of real capabilities? Because, it's one thing for the operators to be able to actually, implement technologies to get them up the curve, but technologically, where are we going to be, through the course of 5G Advanced and then going into 6G? Any thoughts there?
Well, the way that we're looking at it in the Reason Project, which is we work with Ericsson, Nokia, Samsung, and all of these other universities and British telecoms as well, we need to get rid of all of those concepts that are preventing us to scale, such as administrative domains, for example, and look at how can we include zero trust in the architecture such that everything can become a node in the network without creating this friction of separation of parameters. So, for example, that is something that I don't believe 5G is even considering, because no one has ever challenged the concept of administrative domain in networks. And I think the other element that it's going to prevent scale in 5G is that, and that's also linked to your point of features, but I think it's more fundamental, is the fact that in the telecoms industry, we don't really write very good software in terms of, like, we don't use advanced software tools such as agent-based architectures. We don't use microservices as much. We just introduced the service-based architecture in release 15. And that means that we're carrying a lot of legacy architectural components, like such as, the GTP protocol, that are heavy and prevent scaling. So unless we really start, again, thinking how do we program that and how does it actually scale with the use of, advanced messaging systems or microservices and stuff like that, we're just not going to scale at the rate that we need to.
Yeah, actually, that's a good point. And that is exactly the mission of, if you call it 6G. Yeah. If you look into what NextGen is talking about, what is Hexa in Europe is talking about, the microservice-based stuff, we did in packet core, how do you get it ran, and even EV, which is a little bit controversial and stuff. But things like distributed NAS. I mean, NAS right now, the communication between EV and packet core goes through AMF. For what? I mean, if I need to access Google or Yahoo, I can go straight to SMF. So fundamentally, people have realized that this is a rigid architecture. Yeah. But if you talk about scaling, the problem is that some of the algorithms, I don't think necessarily it's a 3GPP's fault, but it's 3GPP and a part of 3GPP too, but it has actually fostered this. Channel estimation, MIMOs, things have not changed. Right. There's no rapid fire innovation. Until now, we're looking into some of the AI-based elements of how do you simplify it. How do you actually fundamentally simplify the whole thing? Yeah. IEEE has some ideas, O-RAN Alliance has some ideas and others, but it's very difficult in the current environment to get some of this. Even split architecture, the frontal split architecture that we talked about, 3GPP, we talked about 6 or 7 of them. O-RAN Alliance, Sun is one, maybe now another version of the things. But even now the debate in 3GPP, because my people are there, say, hey, shouldn't we take it back in 3GPP? So you got to have all the views. But one thing Intel has done, and just the only plug I'll do, 10 years back, we did this FlexRAN that developed. Actually, I architected that one with a small team of investors. It has gone everywhere. Yeah. If, Rakesh talked about his work in Stanford with Wuhan and stuff. I'm assuming there's some contribution of FlexRAN and the platform, the software-defined RAN. That was that you can change it. You can do any algorithm. You can do your stuff, So that helped fostering, some of this aspects.
So maybe one other point to add is, so you talked about, how much of it will get done in the context of 5G advanced and how much for 6G. Because the other thing to take note of, and we should not miss that, is quite a bit of intelligence is going into the network and going into the device right now as speak. When we talk about 3GPP and any relevance to 5G advanced in terms of the releases, it's only when the device and the network have to understand each other in the context of what they're doing as part of AML or anything intelligent in terms of data-driven approaches. Because there is a lot of data on the device side, and the device algorithms are continuously evolving. Right. They are getting more efficient in terms of either computational power or in terms of performance. Similarly, on the network side, quite a bit of that is happening right now. That's not dependent as much on what's happening within 3GPP, and that will continue to go on. Where it becomes important to see, the cadence of 3GPP releases and how much of that actually makes it to the networks and deployments is where the network and the device have to work in conjunction, have to understand, if the network needs some measurement, some kind of data collection reporting from the device, and similarly, the device needs some data which is only available with the network. How do you bring all these parties together? Because again, the ecosystem is very complex. A lot of players, starting with chipset manufacturers, the OEMs. Again, on the network side, you have, and then the operators. So a lot of big players, a lot of, it's a complex ecosystem. How do you bring them all together? That's where 3GPP comes in. Okay, this is unified way in which, you can all talk to each other and make things even better than what they would be otherwise.
So do any of you work with a client who charges you $25 if you say generative AI? No, not yet. Okay. All right. Well, let's talk about generative AI for the moment, but actually more broadly AI, because obviously, everyone's really excited about the new AI, which is generative AI. But as has already been mentioned, we have in the telco industry, we have a long legacy of AI. See, I like that look on your face. Whoops. See, AI on the device too. But what are your thoughts on how AI is going to evolve and what role it will start to take as we move toward 6G and into 6G, right? Because, we've seen several evolutions of AI, right? Now we have these transformer models and large language models and this whole new paradigm that's starting to reinvigorate the conversation, maybe even affect the roadmap. Any thoughts? Ravi, you want to try?
Yeah, so I'll tie it back to the previous comment I made, which is some of the scaling that you were talking about, when is it going to scale? We can ask the question, when is 5G truly going to scale? You can still look at 5G networks today and ask the question, how many of them are truly TDD? And how many of them are truly doing multi-user MIMO? How many of them are truly doing massive MIMO, multi-user MIMO? And it'll be a small fraction. And the reason for that is because the air interface itself is intelligent and not intelligent enough, but configurable enough to be able to extract all that value. The reason you don't see that scaling is because today the operators aren't able to see. If they are able to see 2x, 3x spectral efficiency gain by doing multi-user MIMO, and they are able to improve their top line, it will scale. The reason why it's not scaling is because that's not happening. And the reason why that's not happening is because you need intelligence both on, especially on the base station side, to be able to do the right kind of beamforming, to do the right kind of configuration management. And that requires machine learning. And there are mechanisms already in place where if the base station decides this is the configuration I'm going to use, there are existing mechanisms to communicate that to the UE. So we feel like, for example, just a number, the number of ways SRS can be configured is goes into millions. Truly, millions of ways SRS can be configured. And you cannot expect a rule-based algorithm to figure out what's the best way to configure this. It has to be dynamic, it has to be machine learning based, and it doesn't need to be generative AI. It could be a small model that runs in the base station and updates itself maybe once every minute or something and communicates to the UE, and that'll be fine.
AI is actually helping some of this, to now getting back to be fair, what GPP release 18 is CSI based, exchange data. The AI elements actually for this autoencoder, the actual compressing and decompressing elements already helped quite a bit. That's one of the major things that even telcos and Nokia, Ericsson, they all agree on some of these things that, hey, now what model, transform model has more data points than the existing one. That's a different story. Yeah. But those are the areas that are already happening, to improve the systems. Beamforming, another example of it. But truly, if you want to get to, I think Ravi's demo gave me that thing that he's getting to that stage of this intent-based management. I truly want to do this. Yeah. And I express that. And then, it's not there, but that's the ultimately on the overall orchestration side of it where probably we need to go.
So we're taking it one step further from intent-based management, and we're taking it to the task. And so the way that we see intelligence playing a role in 6G architecture is that you're not going to have just one AI model, you're going to have many. So we created this knowledge layer, and at the base of this knowledge layer is end-to-end AI orchestration. And by what that means is holding a catalog of AI models that you have available. And then there is an orchestration part of that says, okay, so for this task in particular, which is a further granularity of that intent, right? Break that into different tasks of the network and say, okay, so for this task, I'm going to chain these models of AI, right? But then obviously you need to have something on top that says, is this running according to my policies? Is this, and there is where we have the cognitive plane. So the cognitive plane looks at it from a bird's eye view and says, okay, this makes sense. Okay, this doesn't. And how do you do that? We integrate monitoring into all of it. And that monitoring is not only giving you KPIs of the network, it's also monitoring the AI in itself.
How many layers you are adding?
Oh, that's the last one.
Just kidding. Oh, that's good. That's good.
All right, Kiran?
Yeah, so again, one recurring theme when we talk about AML is there are going to be multiple models,
Yeah.
and then the models themselves, but the same functionality will keep evolving. You mentioned transformers today. 6 months from now, it could be the next big thing. And the way to approach this also from a standards point of view, because any time you put something in standards, are we setting something in stone, and are we stuck with that for next 10 years, 15 years for how much ever that particular network and device is going to survive? And mainly to address that, and that's how, again, I'm bringing in 3GPP here, but really that's the mindset that we are also taking in, because it's quite different from the other applications where AML was applied, when you talk about the wireless ecosystem here. And the entire effort here is to make sure that we have a framework where the network and the device can agree on a functionality that they want to support using an AML model. But the exact model that will be deployed is still flexible.
Right.
It's got to be based on negotiation between the network and the device. The network has to understand the choices that the device offers, that these are the models for which I'm tested against. You can't randomly deploy some model on the device and assume that the device can support that. The device may just brick itself in the field and that's it. The user is stuck.
Yeah.
Because you still have to remember that that's still a device that's made to make calls. And apart from data and the computer in your pocket and all of that. Similarly, on the network side, the device has to understand what the network can support. And you need the interoperability, a lot of other things that need to happen. As part of that, entire framework is to make sure it's flexible enough. I know flexibility sometimes comes at a cost. You may end up with a million possible configurations, but still the few configurations that you pick out of those, you have to make sure they can work reliably well. So that's where actually, and that's where the EPV is also taking a little bit of time to say what is that right model. So that's flexible enough, something that can actually carry us into the next 10 years or whatever, is the time duration you want to set up our system.
Okay. Well, I'm going to ask a moonshot question here. Have you guys put on your little fortune teller hat and, pull out your crystal ball? And I want to ask you, what do you think are a couple of the critical or important research areas in AI in particular that you see that the industry needs to focus on in order to make, to carry us through 5G advance into 6G? So I'll tell you, a perfectly acceptable answer is I have no idea. But why don't you guys give it a shot? Who wants to go first?
I can go. Kiran, did you want to?
No, that's fine. I can go too, but
That's a hot potato, right?
So, so I again, my view is we are still in the stage of using existing AI into 5G networks to truly advance spectral efficiency, throughput, better energy efficiency. Existing AI networks and existing AI infrastructures and algorithms, if deployed properly and if chosen correctly, and if the operators and if we can do trials and convince them that this can be done, there's so much potential to be gained just in that. But among that, some of the challenges or some of the edges of that technology which we are yet to scratch is what's called cross-layer optimization. Like, for example, today scheduling is done in layer 2 without truly understanding what's going on in layer 1, or what are the channels that the user is facing, how fast is the user moving. And so some of this cross-layer optimization work becomes kind of starts to look like reinforcement learning based algorithms, but then reinforcement learning has its own problems because it tends to be very unstable. And how do we mimic reinforcement learning by not truly doing reinforcement learning? Can we use some kind of bandit based approach? So some of those things we have been looking at, and those are kind of on the edges of what we would consider traditional machine learning as applied to wireless.
Okay. Yeah, so I mean, just building a little bit on the top of what Ravi just said. So we talk about this notion of an AI native air interface. And again, it's a very broad term. And what do we mean by that? Cross-layer optimization is one example that you brought up. But if you look at how air interface is built up right now, so you have a procedure in place to get your channel state feedback, a procedure in place to get your positioning information, for your beam management, for your scheduling, for your link adaptation. You name it, there's a separate procedure built, and you need to have the device and the network communicate, negotiate, come up with what's the right thing to do at that point in time. If you actually take a step back, a lot of these are driven by the same underlying information. What does the channel look like? Same context that you have in the network as well as with the device. Where is the device at this point? And there's not the first device that was there at that point in time for this network, which is not moving. There are things that are varying in the environment of the network, but by and large, there are a few things that you can learn and carry forward. So there are all these components. When we talk about this AI native air interface, what we are really talking about is essentially, can we give the context of the device to the network and the context of the network to the device so that you don't negotiate on a term by term, functionality by functionality basis. You're now able to make some bigger decisions in terms of, okay, for this device, with this channel condition at this point in time, this is the entire set of configurations that would actually work out the best. And I think with AML, we'll get to that kind of framework where we don't have to break it down and learn and try to optimize for each functionality set.
AI native and cloud native is a tool or sentence that NextGen talks about quite a bit. But I'll tell you what Intel Lab, I mean, we fund our research organizations. What are they looking into? Again, building on some of the stuff that they talked about, some of the fundamental algorithms, if you look into a channel estimation, MIMOs or complex algorithm, that has not changed really. How can I simplify it? If you go everywhere, sustainability is the key aspect of it. That means overall reduce the power, reduce the complexity. So one of the goals that we have in our Intel Lab is essentially, hey, you're applying AI as an element of it, including generative AI. Is it simplifying the implementation? Is it improving the KPIs? Or is it creating additional elements of the algorithm? So we are fundamentally looking into the whole architecture itself, including the communications between networking and the device side of it. So how do you simplify it? And this is where one of the things that, beyond 3GPP, other organizations are also going to play as well. There are interests from IEEE and other organizations as well, and multi-access elements coming into play as well there.
So if I have to think about where the research should be going, I'm not an AI expert. I know nothing about AI as much as I know about systems. So I will go into the application of AI in systems, which is what I am interested in as a technologist in telecoms. So I think there are elements of security that need to be addressed, and more importantly is deployment. Where do we deploy in infrastructure, for example, and that tied into policy-driven decisions? How does your orchestrator actually interact with your AI in a way that you enable some sort of automation, but you are not giving away too much into a third-party application? So that's where kind of like the security and policy approach, it is super important to look into it from a research perspective. And that ties into ETSI, right? So how do we actually build that into your OSS BSS and make sure that it scales, right? Because we all want third parties to create apps and deploy apps, but until we don't solve that big elephant in the room, there's not going to be adoption. So the faster that we look at that from a system level perspective in the research community, we're going to bring the confidence and the trust in the AI third party applications to be deployed in the network.
Okay. And in closing, I want to ask one last question really quickly because, Kiran, you seem to have this fixation on standards.
No, okay. That's what's coming across. Okay, maybe I should. Maybe your last question should be about that, and give me a chance to clear it up. Yeah. No.
Oh, we're gonna find out, right? Especially as it relates to AI. So as we see AI for the network and the air interface and the RAN continue to evolve, what do you guys see as the role of standards as it relates to AI? And what would you standardize, and for what benefit? And I don't know, Ravi, if you want to start off.
No, I would just probably start off by setting the stage that standards and AI hasn't really happened. It's not like telco is behind in any way. If you take any standard location where standards are used, like how do you listen to music? It's still MP3s, and how do you compress images? It's still HEVCs and HEICs. These are all traditional algorithms, and there are lots of, like, for example, Meta has a standards-based audio codec. A machine learning-based audio codec. Will it get standardized? So it has its own challenges when you start trying to standardize a machine learning architecture, because machine learning is more of an approach which is data-driven and optimization-driven. How do you standardize that? I guess my answer is to set the expectations at the right level. It's not an easy thing to do. It's not like telco is behind. There is, as far as I know, there is no machine learning in any standard today. So it's going to happen. We will struggle our way into figuring out something, but that's my take on it. Let's not beat ourselves up too much.
Okay. Any other thoughts?
Yeah, sure. I have to say something.
That's your standards guy.
A lot of thoughts, but depending on how much time you give me. But so again, the two things I think I'd also mentioned this earlier. So yeah, definitely the standards is something that will keep going forward. But even outside of standards, all is really waiting for standards to completely define everything. So network is doing things based on AML methods. Device is doing that. Even if you look at all the Qualcomm announcements, again, not a plug for Qualcomm, but like, if I'm allowed to say one sentence about Qualcomm, that was it. But so all these ML cores are being built in, AML capable and all of that. But then what you'll realize is there's only so far that you can go. The device and the network are working independent of each other. Just given how the ecosystem works, and said, multiple players and all the solutions that you bring to the table have to work with each other.
Yeah.
And standards is the way to do that. If the network, let's say, implement something and assumes that the device is going to feed some data that's going to help it pick the right model to operate and all of that. And if it's not in the standards, it cannot expect every device to give it the data. And same thing for device. And that's where standards become important, not in terms of defining which models to run,
right,
but in a way that the network, the device and the network can talk to each other and figure out, okay, we have what functionality and how do I address this, my available data. So standards has its place to take us beyond a certain point, and that's where Release 18, for instance, looking at some use cases, looking at what you could get if you were to use a standards-defined approach where the UE and network are working in tandem with each other, versus if you were to do something what we call a one-sided model, either on the UE side or network side. And obviously, when they talk to each other, you can do much more, and that's where standards come in. So it's important.
Okay. You say so.
Yeah.
No, awesome. Any final thoughts? Or
Standardize the interfaces and let the innovation inside the little box to have that outside.
But that's exactly the approach that's happening right now. So that the interfaces are what's going to be standardized.
And I would say let's move more, but that's my approach. That it's a bit more like I'm not a standards lover or driven. I think that standards sometimes have killed innovation or slowed it down. Why don't we just take the more software approach to interfaces and data models and information elements? So, like, let's all work under the same conditions, but maybe in a more open source approach.
But who defines these conditions? That's where
the open source community, Linux Foundation and open source community has done that for the enterprise cloud for years and years and years without having, this really privileged position that 3GPP has gained.
Okay.
That's a different.
All right. You guys can take that outside. Yeah, well, you know what? I want to thank our panelists here. I think they did a wonderful job.